So we discussed how to create function handles, which is basically a pointer to the function, to the object that you create, the function that you create. So do you guys know what pointer is? Does anybody have any ideas? I mean, you would probably get the meaning of it because the word pointer means that it points to something, right? Yes?
Is the pointer an example active?
No. So what I wanted to... No. So I'm talking about the handle. So I'm telling you f here in this case, it equals @ my func. F is pointing to my func. When you use that function handle symbol, which is @, basically that @ says f is going to point to this function from now on, right? So whenever you call f, what is stored in f is not this function, right? It's just the instruction to tell MATLAB to go find this function, yes, for you. That's it. So that's basically the idea of pointer, which is really common in other languages like C, C++, Fortran, almost all languages, right? But there is no explicit discussion of it in MATLAB. So what really is happening is underneath MATLAB, it's all coded in C++ probably or C, and you don't explicitly talk about pointers anymore. But then, so I could say f equals, let's say I don't want a pointer to a single function, but rather a list of functions. So for example, you want to list all the trigonometric functions in a single pointer. But you cannot create a single pointer to point to all of them. You need to create a list of function handles. And I told you the equivalent of list in MATLAB is celery. So I could say @ sine, @ cosine, @tan. Now this is going to create a function handle. Function handle, I don't know, FH list, let's call it. FH list, which consists of these three trigonometric functions, right? Now if I say class FH list, what do you think I will get? What is the class of FH list? Yes. There was one correct answer somewhere. Cell, yes. It's a cell. It doesn't matter what the content of the cell is, but it's still a cell, right? But the content of it could be whatever we want. So yeah, so it's a cell type. Now I could call each element of it, so FH list. How do I call the cell array elements? So does this give me the function or not? No, it won't give you. It just gives you the element inside of it. So you could say curly brackets, FH list 1. Now if I say this, what's the type of this function? I'm sorry, this element? It's a function handle, so that's what you get. If you used parentheses, that's not what you get, so you get something different. It's still a cell, but it's just one element of the cell. It's the box itself. Okay, so this is cool because now, for example, you could have a function, you could write a function that has a list of function handles inside of it, and then you want to give these functions, all of them, collectively to the user as the output. So you could create a function handle cell array that contains all of the functions that you define locally inside your function, and then pass it to the user, and then user can call each one of them to use for whatever reason they want. So basically that was it. Then let's see what else we missed in the discussion. Oh, by the way, you can get really complex structures with a structure not in the sense that is defined in MATLAB. You can get really complex objects using function handles. For example, you can define a function handle that takes another function handle, that takes another function handle, and then passes that function to a MATLAB built-in function and does something for you in the end. So there's an example of it, I think, somewhere in the lecture notes. Let me see if I can find it integral. Yes. So here's an example. Let's say we define this function, GC, which is the integral of this quadratic equation, which has this constant of it, C, as a free parameter. So it can change to any number that we want. Now the question is, what is the result of this integral for different values of C? So how do you code this? Too bad I have the answer right beneath it, so I should have removed it to let you think about it. So let's see what this code is doing. Whenever you encounter this a problem like this, you have to break it down to the simplest part and then start from there. That also includes your approach, so that should be also your approach to the final project. So I'm going to give you a project that is, I think, complex. I believe it's complex. So what you need to do is to sit together, probably in groups of 3 or 4, and think about it. Divide the work between yourself. So some of you might become responsible for plotting whatever data that you have. Some other ones might become responsible for fitting model to data, and so on. So that depends on yourself. But you have to modularize your work and say, I want to perform this simple task, and then give you the results in a well-specified way. So the same thing also goes here. So we have this complex function that we want to evaluate for different values of C. So the first step that you have to take is to construct a function handle that takes this form and then calculates this function for you, as a function handle. So let's create a function handle that does this for us. So we have, instead of this, we have x squared plus cx plus 1. So how do you create a function handle for this? Let's say this is my quadratic function handle, so I call it QFH equals, and then I want it to be vectorized, so I add. And by the way, when you have a constant times a vector, you don't need to vectorize it because it's automatically vectorized with this symbol, multiplication symbol. So now that's all we need, QFH. Oh, forgot something. What did I forget? Yes, I need to define what is the variable, what is the input variable. So this is the input variable to my function handle. Now, by the way, function handles are also sometimes called anonymous functions in MATLAB. I think because you don't need to put them in a separate file, so they exist wherever you define them. For that reason, they are also called anonymous functions. So now, if I say QFH1, oh, by the way, here's a problem. We did not define C, right? So let's see what we get if you say QFH1. It gives an error.
Why didn't you put a period after the X?
It's because it makes it vectorized multiplication. So that makes this function a vectorized function. What does it mean? It means that you can now input. What does it mean? Let's ask somebody. Somebody has an answer. Yes. Exactly. Yes. So this basically means that you can multiply two vectors of x with each other element-wise. So you don't need to have always a scalar x. You could also have vector x as input to this function. So let's try it and see. Instead of writing on the blackboard, let's try it and see what happens. So let's define C first. So I'm going to redefine C. For the moment, let's just set it to. Okay. Now, if I say And let's remove this. So make it a scalar, right? Yes?
When I entered that first line, it said that the dot is the period and the exponent sign is an undefined operator.
Is an undefined operator. Okay. Let's try the scalar version first and then see what happens. So this is my function handle, right? It doesn't have the dot notation. And now I can say QFH. What is the result if I input 1 to this function handle? What is it? It's 4, yes. Now, what if I say 1, 1? It's going to give an error. It says the input must be a scalar, right? So this or a square matrix should resolve the problem. But you said it doesn't? Somebody said, well,
If you got 5.7 instead of 4, what could cause that?
the breakdown of science, I think.
Okay.
He has a C defined as 3.7.
Oh, I see. So here's the thing. So you have to be careful because sometimes if you make the mistake that I made here a few minutes ago, like define this QFH in this form with the C instead of a constant factor, then what happens is that if you have already defined C in your workspace here, then the value of C is going to be taken from this workspace and put here. Exactly, whatever it is, right? And then here's the special thing about function handles. As soon as you have the value, the prior value of C in this place, no matter what the value of C will be in future, it's not going to change the function handle. So the function handle is fixed. As soon as you define it, it's fixed. You cannot change it. All the change should appear in the input. So whatever appears here is going to be fixed except X. So if you define C here, C is going to be there forever, whatever value it has at the time of definition. So again, it gives me an error. So if I try this, it defines it, but then I cannot use it because C is not defined yet. You see? So it's a runtime error. But now if I define C to be something 10, or let's set it to 0 for now, and now I define QFH to be this function again with C as a constant factor. Now if I say QFH 1, what do you think I should get?
2.
Yes, I think I should get 2. But now let's set C to 10. What should I get now if I say QFH1?
2.
Yes. Well, it's good because it means you listen to me in class. So QFH equals QFH1 equals 2 again. And why is it so? I'm going to ask some of you. Yes, you. Tell me, I forgot your name. Alex. Is that correct? Okay. Can you tell me why we get 2? So what I did is that I have this function, QFH, this function handle, and C is set to 0. Now I define this function handle. Okay. Now if I say QFH1, what should I get? What? 2. Okay. Now I redefine C to be 10 instead of 0. What should I get as QFH1? Still 2. Okay. Why does this happen? Because I have redefined C. So why doesn't the result change then? I redefined it. Yes. It's actually right there. I redefined C to be 10. Oh, I see. I didn't redefine the function handle. Is that what you mean? Yes. That's correct. Then, yes, the correct answer is that. So the reason you don't get a different answer, so I have to redefine this function, and if I want to get a different answer. Now with C equals to 10, if I redefine QFH, QFH1 is going to be different. Now it's 12, right? Okay. But we were trying to solve this problem. Okay. So the first step is to define a function that takes x and evaluates the quadratic function that we had, quadratic equation. So x, and then it's x squared plus cx plus 1. Okay, but here's the thing. So since we're gonna define this function in multiple layers, and it's a combination of two function handles, and c is a variable for the upper layer of this function handle, we don't need to define a separate function handle for this quadratic function. So first we define x squared plus c times x plus 1. This is the first step. Then we could add it. Yes, I think so. Why not? We could even add it here, but it's not useful because c is a constant. It's not going to make a difference. So QFH, if I define this to be my function, now if I say QFH1, it's going to give me 12 again, right? If I say QFH1 and 1, it's going to give me a vectorized answer, right? So, Marshall, do you see the advantage of having that dot notation there? So instead of defining everything as a scalar, I defined it to be element-wise or vectorized, meaning that if x is now a vector instead of a scalar, I can input a vector x instead of a scalar x, and then get the output as a vector. Right. So what happens is that the MATLAB calculates this function for me once for the value of 1, and the other time for the value of 1. So if I say 1 and 2, then you will see the difference. Oops. Okay, yeah. You get 12 and 25. All right. So you should always try to vectorize your code, and I told you why. What's the reason for vectorizing your code? That's because all of these calculations, MATLAB is smart enough to perform all of these calculations in parallel for you. So your laptops, your computers, whatever you have at this time, they are all multiple core computers, meaning that they have separate units of processing information. So you could simply assign them different tasks to perform for you in parallel. So if this vector, for example, is really long, something like this, then if you vectorize your function, MATLAB could assign each value to a separate processing unit in your computer and say, okay, you go calculate this function for this value of input, and then you go to calculate the function for the other value, and so on for all of them. So you see, you get an output like this. So maybe in future we will get to some real problems where you see the difference between vectorization and scalar calculations. All right. So let's finish this problem that we started 15 minutes ago. We wanted to write a function that calculates this integral for us for different values of c. So at the first step, I define a function handle that takes x and then has c as a constant that has to vary, right? So this is my first level of this function construction, and then I want the integral of this function from 0 to 1, right? So MATLAB has a built-in integral function which takes a function as input. So you see, this is one of the uses of a function handle. You can create them to pass it to another function for evaluation. So it's most useful for mathematical functions, right? And then I say the range of the integration is from 0 to 1. Now, what is the problem with this equation, or with this function evaluation? Yes, c C is not defined. But let's see what happens. To be honest, I don't know what's going to happen because we have already defined C. Let's see what happens if we just say integral of this function from 0 to 1 with C undefined. It gives us an answer. Okay. Why does it give us an answer? C was already defined, right? So in order to make it a variable, we have to put this into another. So we have to define a grand function, g of x. G equals, what is our variable? C, yes. So I could say integral. So this is my function. This is the function I want to evaluate. My input variable is C, and this is the function itself. So now if I define C to be G to be this, now if I say G12, what should I get? Oh no, it's actually G10. I should get exact same answer as above because C is already 10, right? So what is C? C is 10. So if I say G of 10, it should give me the exact same answer as 6.3333, right? And that's the same answer. Okay.
So,
Yes.
when we make G of 10, does the x and the c both are defined as 10?
No. So x is a variable for the integral function, right? So the integral function takes this function as input, and then it wants to evaluate the integral of this function handle, from 0 to 1. So what it does is that this integral function creates, so this is x, and this is the function value, right? The function handle value, right? So this integral function says the user requested me to calculate the integral of this function from 0 to 1. So what I'm going to do is that I'll create small rectangles at different values of x. And now, what do you need to calculate the area beneath this curve? You need the height for each rectangle. If you want to approximate the area beneath this curve, you can just simply assume these are rectangles, right? You see what I'm doing? So you create a small rectangle, and then what do you need to calculate the area of each rectangle? I'm going to ask someone who doesn't look at the board. Like, I forgot your name. You're good looking guy, yeah. No, I don't want you. I want the person behind you. Yes. What was your name?
I'm Cameron.
Cameron?
Yeah.
Yes. So how do you calculate the area beneath each one of these rectangles? I mean, how do you calculate the area of each one of these rectangles? It's base times height, right? So what is the height?
Y.
Yes, it's not y. We don't have y. We have f of x, which is the function handle value, right? So, but how about the base?
That's just your x.
Yes. So the base is calculated by the integral built-in function in MATLAB. So you have the built-in function integral, which what it does is that it takes the function handle, f of x, as input, and also the range of integration from 0 to 1. So what it does is that it creates a fine grid in the x direction. So it creates a vector of x values, 0, 0.1, 0.2, 0.3, and so on, right? And the difference between each one is 1, right? So the base of all of these rectangles is 1, and the height is what? For each one, the height, you just input the value of x, you get the height value, right? So you multiply them together, and you get the area of each rectangle, and then you sum over all of them. That's basically what the integral function does. So going back to your question, x is a variable for the integral function. So we don't need to define it here in this function. See? So, I'm sorry, x is a variable for this function, that's correct. C is not a variable for this function. C is constant. So C is given to the integral function when it's when you're trying to calculate it. Okay, so x should not appear here with c. Otherwise, you would get wrong answers. We can try it and see. What do you think will happen? It's not going to give you a wrong. It's not going to give you an error. So the question is, what if we, instead of having x here, we put x here? What would happen? I think this is going to give you an error, but let's see. Or no, maybe it will not give you an error, but this is wrong in any way. Okay, it worked, but it's not gonna affect our results in any way, because why do you think it's not gonna affect the results? Let's try it first and see what happens with this. So if I say g of 10, it's gonna give me the exact same answer. Why do you think the addition of x here doesn't have any effect on this function? Evaluate.
X is already controlled by the function handle and the integral.
Good, but that's not the whole answer. There is another sentence that completes it. So the thing is that this x is not the same x that you have here. So your first sentence is correct, because but basically what you said is that this x here is controlled by this function handle. That's fine, but you have an input variable here, x, for the grand function, the integral, but this integral doesn't have any x for itself explicitly. You see what's happening here? So you have two x's. These are two different entities. This x is internal. This is for the function handle itself. But this x is for this integral function on the grander scale. But we don't have any x value explicitly in this integral function. If you want to make your integral sensitive to x, you have to put it explicitly in your integral function. How do I do that, for example? Can you suggest some changes in this function handle that makes it sensitive to value of x, the input x that I put here?
Multiply x by the integral function.
That would be one solution, I think. Maybe I'm not sure if it works. But let me try the first simple way of changing this function. Change the range and set it to x. Now, so you see there are now two x's, and these are two different things. There is one x that is for the internal function, this function handle that gives us the quadratic function. There is another x which has no relevance or nothing in connection with this function. And that's about the input argument of this whole function g, right? So these two x's are not the same at all. Now, if I say g of 10 and 1, what should I get? I should still get the same answer as before, because originally I defined it as 1, right? No, wait. Okay, so now it's correct. But now if I say g of 1, 2, it's going to be different, because now the range of integration is from 0 to 2, not from... Yes, right.
So when you put the arguments in for g, what is 10? What is 2?
Okay,
Related
so
to that function.
it's in the order that you define in function. So you set c to be the first input variable and x the second.
Yes.
Right? So when you call the function, you have to preserve the same order when you call the function g. So you have to say g, whatever I input as the first variable, that's going to be the value of c, because that's how I define the function.
Okay, so you're saying if c is equal to 10 and x is equal to 2,
Yes.
that's what this will be.
Yes.
That's what the integral.
Yes, exactly.
Okay.
Yes. But this x has no connection whatsoever to the x that we have defined here in this function.
Right, that's just the
To be
handle, right?
Yes, that's just a dummy argument for the internal function. It could be anything, and it has no relevance to the explicit x that we define on the higher level.
And when you place a period next to one of those variables, each variable with a period will become a new element within that vector. Is that correct?
No. So the point, the dot, goes with the operator. So whenever you put a dot before an operator, which is only exponentiation division, and multiplication. What it does is that it will make it a vectorized operation, meaning that if you try to take the power of x to 2, for example, then all the elements of x, if it's a vector, will be taken to the power of 2. Right? So now, since I have defined this to be a vector, but here's the thing. The problem is that integral, okay, so you cannot, so basically this vectorization here helps the integral function to evaluate it much faster than it could with a scalar definition. I'm even not sure if it will accept a scalar definition. We can try it. I think it will not work because integral probably by default assumes a vectorized function. Let's try it and see. Not enough arguments. What does it mean? Okay, that's correct. Now let's say G2. You see? It gives me a long list of errors. Why do you think this happened?
Because you removed the periods.
Yes, but yeah, that's a good point. Yes, but what's the effects of removing the periods there in the function? It makes it a scalar function, right? But why does it give me an error? Because
The scalar.
Because the integral function takes a vectorized function as input by default, right? It doesn't work with the scalar functions because it wants to expedite. So MATLAB developers have defined integral function by default for input functions that are vectorized already. So if your function is not vectorized, then you cannot call the integral function using that function. Input functions, all right? Okay. Now it's time to wake up. How about a quiz? Yeah? All right, so I told you about the other name of this function handlers, anonymous functions, but you could also have functions that do not have any input, function handles. So I told you that if your function has any input variables, you can put it there, like x, y, whatever. But if there is no input argument to your function handle, then that's it. And date str gives you the date, the current date. Not enough input arguments. What happened? No, t. Now if I say t, what do I get? No, you don't get today's date. Exactly. You get the function value, which is this. So it gives you the value of the variable, right? Which is this function handle. So how do I get the function to work? How do I call this function handle instead of just type? Yes. So this is how you call the function when it doesn't have any arguments. You see? So you can define function handlers in this way, and it's really cool. Instead of just typing data str now, to define a simple single character as this function using the function handle notation, and then you can use it throughout your code, your script function, whatever you have. Right. So I want to tell you something else I forgot. Oh, by the way, so let's say now that I define s equals t, what's going to happen? Yes, excellent. So what was the value of t? I told you when you have the equality sign assignment, basically you copy the value of t and put it in the other variable that you define on the left side. So s is going to have the value of t from now on, right? But what was the value of t? It was this, not the output of the function that is inside of t. So the value of t is this function handle. So now if I say s, it's going to be the same thing. If I say s parenthesis, It's going to perform the same task for us, right? So this is again the same idea as pointers that you see in other languages. So we are creating pointers to the same object, right? So for example, each one of you could be a pointer to me. You point to me and say, like for example, this is this instructor for this course, right? So you're not the instructor yourself, you're just pointing to me and saying that this is this instructor, right? The same way here. These variables are not the functions itself, these are just pointers to the function that we defined originally, right? So that said, I told you also how to create function handles that take multiple input arguments and also output multiple output arguments. Like this one, for example. This is a cool one, so let's try it and see. We'll get to plotting soon, but you can search for MyGrid in the web page of the course in this lecture and get this line, or just type whatever I have here. So what I'm doing here is that there's a function ndGrid that creates a mesh of the space that you defined within these limits, x and y. So basically, I'm creating a mesh of the space. Just like this, in the x and y directions. I haven't created yet, but I just defined a function handle, MyGrid, that takes 3 arguments, the range for the x direction and the range for the y direction, and then a constant c which defines the, what does it define? Constant c. Look at the equation that I have here. So what is the meaning of this x colon x divided by c x? So if I say -10 colon 2 10, what is the output of this? This is a shorthand in MATLAB to create a vector that goes from -10 with the steps of 2, size 2, up to 10, right? So it gives you a vector that starts from -10, -8, -6, and so on up to 10, right? So I could just simply set this to a variable and say -10 to 10 equals t. Now t is this, right? So when I say MyGrid is this function handle that takes x and y and c, so now what does c do in this example? I'm going to ask someone again who doesn't pay attention. What does C do? Call your friend next to you who's looking backwards. What does C do in this example? So I told you that what this notation does, it takes the x variable, so it creates a vector that starts from -10 with the skips of 2 up to 10, right? So now, what is the value, what does C do in this case then? You want to say it better? It looks like you know the answer.
Well, it's basically deciding how many increments, or like how many numbers.
Exactly. There's a word for it. It's called the resolution, right? It defines the resolution of your grid that you're trying to define. So if I increase C, then this number is going to be really small, right? So that increases the resolution of the grid. So if I say 0.2 here, the skips are going to be really small. So you're going to get a lot of numbers, right? So you basically get around 100 numbers. Whereas if you say 2, you get very few, right? So this basically defines the resolution. So when I say go from negative x to x with the skips of x divided by c, then c defines the resolution of your grid. All right? So let's define this function, my grid. And then this MATLAB built-in function, the ND grid, outputs two matrices, two square matrices for you, x and y, which you can use to make some nice plots. Now you need to define a third variable, z, which is sine of x and cosine of y. So y and x are both matrices. They are not scalar variables. So they are matrices of values, right? So I'm going to define z. So then what's going to be the value of z? Yes. So now if you look at z is going to be matrix because x and y are, both of them are matrices. So z is going to be a matrix that has values in both x and y direction, right? Now I have, so what I have been doing so far, yes, go ahead.
If you take the sign of a matrix, is that like element-wise?
Yes, element-wise. Yes, very good point. So all of these functions are elemental. That's the word that they use. Programmers use sometimes, meaning that they work on elements of vectors that are input to these functions, right? So whenever you define a vectorized function, your function is called elemental, meaning that it works with the elements of the input variable, right? And then outputs the result, again, element-wise. So I have three variables now, x, y, and z, each one of which defines a matrix. So I can now construct a three-dimensional plot of these three variables. And to do that, you need to use mesh. MATLAB's built-in mesh function. It takes x, which is a matrix that defines the values of the function in the x direction, and then the y, which gives us the coordinates. Basically, these two gives us the coordinates, and then the z variable gives us the function value at points x and y. Right. So that's what we have been doing so far. And now if I press enter, it's going to plot something fancy for us. Right. So this is x direction, this is y. I think this is x, this is y, and then this is z direction. And this is sine of x plus cosine of x, cosine of y. Yes. Yes, unfortunately, yes. To be honest, I've been working with these functions for years now, but I still don't understand why they needed to define x to be a matrix instead of a vector, because you could simply have, if you look at the structure of x, you will see that there is a lot of redundant information in it. So see, the rows in x have all the same values, right? So the first row is all negative 3.1. The second row is negative 2.8, all of it. So there is a lot of redundancy here. Why would you need that redundancy? I don't know. That's how they defined it. So what you really need is just a vector of x and a vector of y, not a matrix. So the y is defined column-wise, unlike x. So basically, what I have been doing here is that if you want to create a three-dimensional plot, all you need to have x values, y values, and z. So I say, give me the function values in these x points and also in these y points. So I create a mesh, I create a grid. And then I calculate the function in these nodes, the function value in these nodes. And then for each function value, I get a point somewhere in the space here. That's basically what I plotted there for you. But MATLAB, the way it does it, you see, if I want to know the values of the x's of the nodes for all of these nodes, I don't need to have a matrix to store all the x values. But MATLAB does it this way. I could simply store the x values on this axis here, say all my x's are 1, 2, 3, 4, 5, 6, all my y's are 1, 2, 3, 4, 5, 6, and the rest of them are all the same. So you don't need to create a matrix for each one of these vectors, for each one of these axes. You see what I mean, or is it like too complex? Or no, you don't get it? Okay, good. I'm really happy that you stayed. Honestly, so you don't need to get it because it's all about plots. So don't worry about it. I told you it's been like a couple of years. I still don't understand it myself, so don't worry about it. What was that?
The integral function, if it really does like ring on sums like that, how accurate is it?
What was the question?
It does the rectangles.
Yes.
But how accurate is it really? That's not that accurate.
Oh, that's a good point. So that was just the explanation, simple explanation, but it doesn't really do that.
Okay.
What it does, you mean for the integration, right?
Right.
Yes. For the integration, it does much more complex things than that. For example, you could have trapezoidal rule, which instead of rectangles, it creates objects like this. So instead of having these extra spaces here, which give you extra error in your calculations, you could simply draw a line between these 2 points. You could go higher order. Instead of having a straight line, you could interpolate this area with a quadratic function, which is curved a little bit, and so on. You could go to higher degrees of polynomial interpolation and get the result. But you're probably going to learn about it in a year or two in your computational engineering course. Well, that was a good point.
Wait, but when you're doing the integral in MATLAB, it's giving you the right answer.
Yes, because the thing is,
It's not doing it in increments that big.
yes, so the thing is that you can always reduce the resolution of integration, increase the resolution of integration and get the correct answer, no matter what method you use. So different methods have different accuracies, but if you resolve your integration a lot, then all of them are going to give you pretty much the same answer, right? But if you go to really complex problems that have like 4 layers of integration on top of each other, then these simple methods are not going to work because they are just too inefficient. You have to resolve your integration a lot in order to get the correct answer. So you go to higher order integration methods. I'll see you Monday. Monday we're going to have a quiz.
I would not expect it.
Oh, because it just doesn't work that way. Yeah, most often you have to solve it numerically.
So they would maybe expect that if you were going to do the integral with the function, then you would just
Yes, exactly, yes. Mathematica has some capabilities to calculate the integral function analytically, but most often you don't get it analytical results. There's no way but to calculate the integral analytically. Numerically, yes.
I have a question today.
Yes, go ahead.